Hi, welcome to this lesson on number patterns, infinite geometric series. Let's have a look at question 2 on solving infinite geometric series problems. They want us to calculate the value of this following series here. A half plus 3/4 plus 9/8 plus 27/16 and so on. Well, first of all, is this a geometric sequence? Does it satisfy this formula here? Well, let's see. The first term here, a is a half. To get to 3/4, I must multiply the numerator by 3 and the denominator by 2. So I multiply by 3 over 2 here and I get 3/4. If I multiply by 3 over 2 again, I do get 9 over 8. If I multiply by 3 over 2 again, I do get 27/16. So this is definitely a geometric sequence. My a value is a half, my r value is 3 over 2. This wants us to add up infinitely many terms, so therefore we want to find S infinity. So can I go ahead and use the formula for S infinity? That's the big question. Well, we can only use it if it meets the golden property. What is that golden property again? Your R value lies between -1 and +1. So again, on the number line, if I try to visualize it, R equals 3 over 2. So here's -1, here's +1. 3 over 2 is 1.5. That's outside here, 1.5. But my interval for convergence is between -1 and 1. This is outside there. So this is in the interval of divergence. So we can say, since my R value is greater than 1, so it's definitely not in between -1 and 1, because my R is 3 over 2, we can therefore say, so then S infinity diverges, and because you're adding infinitely many positive numbers, it diverges to positive infinity. Okay, so in this scenario, even though it was a geometric series, adding it up infinitely many times does not give you a finite value. This diverges. And again, if you look at a number line, to try and visualize it. So let's imagine you start at a half here, then you start at 1, 2, 3, 4. So a half is over here, so you've added that many units first, then you've added 3/4, right? So that's 2/4, 3/4, so now you've added up to here. So if I add that 3/4, so let's do that, a half plus 3/4, I can rewrite a half as 2/4. So I get 5/4, so that's 5 over 4 here. If you add 9/8, so that's adding, remember 9/8 is 1 and 1/8 in improper fractions terms. But let's just say rather that we are adding, so from 5/4, we're adding 5 over 4 plus 9 over 8. I'm going to rewrite 5 over 4 as 10 over 8 plus 9 over 8. That'll give me 19 over 8. So we know 8 goes into 19 2 times, 16, remainder 3. So 2 and 3/8. So that ends up being somewhere here. So it looks like these little intervals that we are adding each time are getting bigger and bigger and bigger each time. So if we keep adding infinitely many of them, we do expect this to diverge off to positive infinity. Okay, so here it does not converge, it diverges because R is greater than 1. Therefore, the infinite sum here of that series does not exist. It diverges off to positive infinity. All right, I'll see you in the next one.